Hello everyone, welcome back to Calculus 2. So in this video, we are going to talk about 1.5 substitution method. So this is one of the integral techniques that you're going to use a lot entire semester. So I'm going to give you guys the idea, why and how we're going to use this. So let's take a look at the definition of the substitution with, integral techniques. So here we go. So far we've been talking about the benefit of using integral in Calculus 2. So we know if you have a function, let's say this is f of x function, and by taking, the integral symbol, and then you've been able to find out the area with the specific interval between a and b, and then that's going to give you the answer, correct? But here is the question. The f of x. Actually, there is a dx at the end. So let me write it dx because we are taking the dx with the respect to x variable. So when I look at this f function, this is the function, correct? How many functions do you know? So what I'm saying is, since pre-calculus and calculus 1, you've been dealing with so many different types of functions, such as a linear function, quadratic function, polynomial function, rational function, trigonometric function, or composite function, right? Exactly. You never know what kind of function you are going to deal with to take the integral, correct? So here is the case. If you have composition function, especially if you have a composition function, we are going to use substitution method to take the integral in an efficient way. So the formula here looks so ugly. I totally got you. So let me show you the example. Hey. So in this integral, they're dealing with x minus 2 to the 4. So what does that mean? You are multiplying x minus 2, you're multiplying the same function 4 times. In other words, this is the composition function, which means one of the function has been subbed into another function. So let's take a look at the structure of this composition function. So I have f of x, let's say I have f of x, which is whatever to the 4th. So let's say you have an outside function, something to the 4th, and you have inside function, specifically x minus 2, and this x minus 2 has been subbed into the outside function. So we talk about this relationship. The g function has been subbed into the f function. We call that is a composition function. So you are basically dealing with two functions. One is the outside big structure, and another one is inside that is a sub into another one. So we have, we call that is the kind of function as a composition function. So this is the question. How would you be able to take the integral if you have a composition function, right? So that in that case, we're going to use the substitution method. Okay, so here is the skill. You are going to, many textbooks saying that use substitution because we're going to say the inside function is going to be the u, so that we're going to make this function is more simply calculated. So let me show you how to take the substitution method. So I'm going to write something. When you have composite function, so you know now what they mean, composition function, something is inside of, something is inside function and another one is outside function. So one of the function is sub into another one. Then, or when you have a composition function, use substitution method. So this is a very, very, very important technique. Okay, this is one of the important integral techniques. So we're gonna take a look at the following question one more time. So here, so I found out that g function, x minus 2, that is my inside, that is my sub function. So you're gonna say let u equal to x minus 2. Okay, this is how we call u substitution method. And then the step is you are going to take the derivative. So you're gonna take the u equation with respect to x variable, so du over dx. You're gonna take the derivative, x minus 2. So x is gonna be 1, 2 is gonna be 0, correct? So simply I'm taking the derivative. So du over dx will be 1, correct? And now I'm gonna just, change that order. So du, I can do the cross multiplication because 1 is the same as a 1 over 1. So we have a du equal to dx relationship. So this is something you're gonna do in the first step. And then let me just make a little bit of space. So then I'm gonna go back to the same color. So we have x minus 2 to the 4 dx. And then what happened? I just told you the x minus 2, that's my sub function, g function. You are going to, that is u, right? That is my u. So the u to the 4. And dx, we just proved that it's the same as a du. So everything is change it from x into the u variable. So that's how you are going to simplify. So this is going to be here. So this work has been in this process. So since we just found out that the function that we are taking, the integral, is a composition function. So by taking the u substitution method, I said the inside function is going to be u, take the derivative. So we found out du equal to dx. That is a u, that is a du. So we change that. Why? So now you can take the integral with respect to u variable. So simply u, 4 plus 1 divided by 5 plus c. And then u to the 5th over 5 plus c. So this is in terms of the u variable. You can go back to the x variable because you know that u was x minus 2 to the 5th over 5 plus c. So this is answer in terms of the x variable. So that's your answer. You just took the integral of that composition function by using the u substitution method. Does it make sense to you? So the key point is you're gonna find out the sub function, the g, right? And then take the derivative to simplify dx to the u in terms of the u variable. So therefore, because this is we don't know how to take that, integral. Are you really gonna expand it and then take the integral? You can try it, but it takes a long time. So the simple way is using the u substitution, you're gonna change all the x variable in terms of the u, then take the integral, it's gonna be more shortcut. Okay, so think about it. The idea is when you have a composition function, please use a u substitution method so you can have, two answers. One is in terms of the u variable or x variable. Usually the answer with the x variable is the better answer. Okay, so that's it. We're gonna keep practicing how to apply the u substitution method with the following questions. Okay, are you guys excited? I hope to see you guys in a real, like face. But anyway, I'm pretty sure you guys show me your thumbs up, right? So let's go to the couple more example. So here we go. So first step is check what kinds of function you are dealing with. So we have 2x to the second times 4x to the third minus 1 to the second power. So what do you guys think? 4x to the third minus 1 has been subbed into the quadratic function. So there is a quadratic function. Let's say this is f of x. And then 4x to the third minus 1, let's say this is a g function. This g function has been subbed into the f function. So definitely this function is part of the composition function, correct? So we're gonna set it up. Let u, that's gonna be your sub function, 4x to the third minus 1. We're looking for the u prime because we're gonna change all the equation in terms of the u. So take the derivative. So du, we are taking the derivative u equation in terms of the x. So 4x to the third is going to be 12 because of 4 times 3, 12. X to the second minus 1 becomes 0. And then this is the same as 12x to the second over 1. So now you can do the cross multiplication. So du will be 12x to the second times dx. Are you guys okay? So here we took the, u substitution method. And then let's look at this. This 2x second times dx also need to change in terms of the u variable. So we're gonna modify a little bit. Watch me. Here, what if you multiply 1/6 both sides? What happened? 1/6, right? We times du, and then you have a 1/6 on the right side, 12x to the second dx. So therefore, this is going to be, so let me write it here, 1/6 du equal to cancel 2x second dx. Dun, 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 dun. Wait. This 2x second times dx is right there. This 2 multiplication is the same as 1/6 times du. The reason why I'm multiplying 1/6, I want to find out what the 2x second times dx is going to be in terms of u variable. So that is going to be 1/6 du. So now everything is here. So now we have this equation. Let me write here. Integral 2x second 4x third minus 1 to the second dx equal to this 2, right? And then we have u to the second times, right? And then we just found out 2x times dx, that is 1/6 du. Am I correct? So now everything is in terms of the u variable. Now you can take the integral simply. So therefore, 1/6 to the front, u to the second, du, 1/6, and then u to the 2 plus 1 divided by 3 plus c, 1/18, u to the third, and then you can go back to the x variable. U was 4x to the third minus 1 to the third plus c. So that's your answer. Does it make sense to you? Sometimes you need to modify to find out what the 2x second times dx change it to in terms of the u variable. So think about it. This is not really complicated concept. Well, like this is a so difficult function. If you try to expand it, it takes a long time and complicated. So instead of doing that way, we are changing all the x variable in terms of u variable by using the u substitution, so that the integral part is so simple. So that's why we are using the u substitution method when you're dealing with the composition function. Okay, we are good to go. So hold up there. We're gonna practice more and more example. Okay, so maybe you could pause the video and you can rewatch. Let's go to the next example. All right, here. So we need to see the structure 4x over radical x to the second plus 9. So you see that x to the second plus 9 has been subbed into the radical function, correct? So I will say, I'm gonna use a u substitution. So therefore, you let u equal to x second plus 9. And then we're gonna take the derivative du over dx, 2x, correct? And then it's going to be cross multiplication. Du will be 2x times dx. That's your u substitution. And now I need to find out 4x times dx. We need to convert 4x times dx in terms of the u variable. So what do you guys think? Here you multiply 2, both of sides. What happened? So it's going to be 2 times du equal 2 times 2x dx. If you multiply 2, you have a 2 du equal to 4x dx, which is 4x dx. We can convert it to 2 times du, 2 du. So that's what we got. So 2 du, it's going to be 4x times dx. So therefore, we have a 4x over radical x second 9x dx. All the information, we're going to convert it in terms of the u variable. So integral, I'm going to 1 over u, radical u, and then 4x times dx. We found out that is a 2 du. Are you guys okay? So that's what happened. And then we're going to take the integral. So this means 1 over radical is a half exponent, and I'm going to bring 2 to the front. Are we okay? And then that means integral, you can do the reverse u to the negative 1 over 2 du, correct? Because it's a reciprocal. So now you're going to take the integral. So u minus 1 over 2 plus 1 divided by that exponent. So negative 1 over 2 plus 1 is a positive 1 over 2 du. So this is a little bit ugly. I can bring this denominator, bring to the numerator, but then you have the reciprocal. So 1 over 2 becomes a 2. And u, negative 1 over 2 plus 1 is positive 1 over 2, and we have a plus c. So there's no more du because we had a plus c. And then for u to the 1 over 2c, this means for radical u plus c. If you want to, you can go back to the x variable. For radical x second plus 9x plus c, that's your answer in terms of the x variable. So think about it. You're gonna modify to find out the remaining information to convert in terms of the u variable. That's the u substitution method. So we're gonna keep practicing, keep on going. So I hope you're gaining a better confidence. Are you guys happy? I hope so. I love to see your thumbs up or smiling. So I'm pretty sure you guys are smiling, hopefully. So take a look at that steps. And I'm gonna do a couple more, a lot of practice today. So let's go to the next example. So here we go. So I do have a cosine third x times a sine x. So if you want, let's think about what that means here. This means cosine to the third x means cosine x to the third power, same meaning. That means cosine x times cosine x times a cosine x. So depending on the textbook, sometimes they are using third inside or outside. But anyway, what do you guys think? Cosine has been subbed into the cubic function. So if I modify, this means cosine x has been subbed into the cubic function, and there's a multiplication sine x. So I see, cosine x has been subbed. And then you're going to find out sine x times dx in terms of the u variable. So I'm going to do that way exactly. So let u, right? You're going to say cosine x. because that's been subbed into the cubic function. Take the derivative. So du over dx, go to the table, differentiation table. If you take the derivative of cosine x, that is a negative sine x, correct? So if you do the cross multiplication, that means du equal to negative sine x dx. Dun, 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 dun. So very similar, negative sine x, positive sine x. So I'm going to multiply negative both of sides. So it's going to be negative du double negative sine x dx. So we found it. Sine x times dx, that is the same as negative du. So that's your u substitution. Now we're going to solve the rest of the question. Integral u to the third, and we found out sine x dx, that's negative du. I can bring negative to the front, so you're taking u to the third du, so that is going to be negative u to the 4 divided by 4 plus c. That's it. You can go back to the x variable, negative cosine x to the 4, that's 4 over 4 plus c. That's your answer. Better and better. Okay, so you are working on it. You are doing awesome. Because we're gonna see a lot of composition function, and then you guys feel, oh, I have to use a substitution method. So likewise, we're gonna keep on going. The next question, x times sine, and then inside 3x to the second power has been subbed. So think about it. You have to see the structure. There is a sine x function, and then 3x to the second, that's your g, and then let's say this is f. This g function has been subbed into the x, sine x function, correct? Definitely, this is a composition function. So I'm gonna say 3x to the second, I'm gonna set it up, that's my u. So you let u equal to 3x to the second, because that's a sub. Du, take the derivative, will be 6x. And you're gonna do the cross multiplication. Du will be 6x times du. Do I have a 6x times du? We need what? Do we need x times dx? I need x times dx, but we have a 6x, so what happened? Ooh, you're gonna divide it by 6 on both of sides. So that is going to be 1 over 6 du, 1 over 6, 6x du. So they're gonna cancel. And let me minimize it. So what happened? We have 1 over 6 du equal to x times du. That's what I want. So x times dx, that is going to be 1 over 6 du in terms of the u variable. So that is going to be our u substitution. So let me just minimize it, because I'm going to need a space. So we good. So therefore, we're going to finalize it. So therefore, f x times sine 3x second dx. Now this is equal to sine u, right? 3x second, that's my u. And then x times dx, that's my 1 over 6 du. So I'm going to bring 1 over 6 to the front. We have a sine u du. Okay, we got it. What is the integral of the sine u? Or sine x, you can think about a sine x. What is the integral of the sine? That's a negative. So we got 1 over 6 negative cosine u plus c. And I can bring negative to the front, cosine u plus c. You can go back to the x variable if you want. Negative 1 over 6 cosine 3x second plus c. So I'm gonna make a little bit of space. So that's your answer. You got it? This is not 6. This is a C. So let me just write it, plus a C. Does it make sense to you? So many people forgot integral. So I'm going to change the color for you. Long time ago, or go to table integral. Sine x is a negative cosine x. So that's what I did right there. Okay. Awesome, awesome, awesome. We're doing awesome. Okay, so we're gonna take a look at 3 more examples. Hang in there. It's fun topic, isn't it? So you have a better confidence at this moment. I'm pretty sure you guys are doing awesome. So let's go to the following example 3. Okay, so I see you. What's going on here? So we have a radical function, right? And then 1 minus x, the linear has been subbed into the radical function. So definitely this is this, composition function. So we know 1 minus x has been subbed, and maybe you need to find out x times dx in terms of the u variable. So let's set it up. U equal 1 minus x, and then du over dx, it's going to be 0 and minus 1. So we have a du equal to negative 1 times dx, negative dx. So what do you guys think? Here, I want to find out what the x times the dx, correct? But I don't have x. We don't have x. So we have to do another way. So this is a use substitution, but we found a little bit of limitation because there's no way. What is x times dx? There's no x. So something we need to do it again. So here, I'm going to modify my u. So u is anyway 1 minus x. I can modify this equation in terms of the x. So let's solve for x. So if you solve for x, u minus 1 will be negative x. And then just you're gonna, change the spot. So 1 minus u will be positive x. So I'm just solving for x, right? So u equal to 1 minus x, or if you want, if you confuse, I say u equal to 1 minus x. You're gonna subtract 1 on both of sides. U minus 1, so minus x divided by negative 1 everywhere, negative u plus 1 positive x. This means x equal to 1 minus u. Okay, something I can do. X is 1 minus u. So we just need to convert whatever x variable in terms of u. Oh, maybe we could use this. Okay, so watch me. So we have these 2 information. Du equal to negative dx or dx. So I'm going to just modify here. From here, negative du equal to positive dx. They're same thing. So let me get rid of it. So we have this 2 information, correct? From the u substitution. So I'm going to modify this. What happened? Integral inside u, because 1 minus x is anyway u. And then x, actually, you know what? Let me just write it. X radical 1 minus x dx. Oh, we have everything. X is 1 minus u. Radical 1 minus x, that's a radical u. Dx is a negative du. So I can convert whatever the x variable in terms of u. Dun, 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 dun. So integral, you are actually 1 over u, radical u minus du. We are taking the integral of this. So therefore, I'm going to bring negative to the front. 1 minus u, radical u, du. Got you. So we are working on this. We're going to take the integral. So here, 1 minus u, and radical u means u to the 1 over 2 du. Am I okay? So let me make a little bit of space. So here, let's do all the distributive property. So negative 1 times u to the 1 over 2 minus u. So there's invisible 1. So 1 plus 1 over 2, 3 over 2 du. I'm keep simplifying further. This means you can have, now you can take the integral negative u 1 over 2 plus 1 divided by that exponent 3 over 2 minus u 3 over 2 plus 1 over 5 over 2. Beautiful. Am I okay? Now the denominator is ugly, so I can bring this one to the top, flipping over. So that would be negative 2 over 3 u to the 3 over 2 minus 2 over 5 u to the 5 over 2. So I'm going to do the distributive property with the negative one more time. Negative 2 over 3 u to the 3 over 2. Double negative change to positive 2 over 5 u to the 5 over 2. So that's the answer in terms of plus c, u variable. If you really want, you can go back to the x variable. What was my x? My x, actually my u is 1 minus x. So minus 2 over 3, 1 minus x to the 3 over 2, 2 over 5, 1 minus x to the 5 over 2 plus c. Dun, 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 dun. That's your answer. So this question was a little bit tough because we had a limitation, to find out what the x times dx in terms of u directly, so that you have to modify a little bit what the x can be, in terms of the u variable. So I solve for x. So we have two information, x equal to 1 over x, 1 over u, 1 minus u, and dx is negative du. So you can convert whatever every information in terms of the u variable. Then you're gonna take the integral. Are you okay with that? That's it. So we've been practicing how to take the integral technique so far. How you feel? Are you happy? Are you okay? Right? So far, so good. So what I'm gonna do, I'm gonna just do two more questions, right? It's a so far so good. We are doing awesome. So what happened is the next concept. What if I'm giving you the specific interval? So far, when you look at the previous question, I didn't give you the specific, interval, of the x. So we're just simply taking the integral. So what if we are dealing with the definite integral from whatever to when, right? So the only different thing is you have a given interval, and at the end, you're gonna do capital letter B minus capital letter A. That's something you're gonna do at the end. Just where, you're gonna get the better answer. So let's take a look at the example. Don't worry, you already learned how to solve this question. Don't memorize the formula. We already know what the characteristic of the substitution function. We know when and how to use it. So let's look at the structure. Ooh, awesome. Directly, you can feel it. 3x second minus 4 has been solved into the fifth function. And then something you feel like I need to find out x times dx in terms of the u. And we have a specific interval from 0 to 1. Great. So we know what's going to do. Let u, 3x second minus 4. Take the derivative du over dx, 6x. And then cross multiplication, du will be 6x times dx. Dun, 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 dun. And I know I want to find out x times dx. I'm going to divide it by 6, both of sides. So this is going to be 1 over 6 du, or you just divide it by, right? du over 6, 6x dx divided by 6. So therefore 1 over 6 du, cancel, x times dx. So we got it. We got x times dx, that is going to be 1 over 6 du in terms of the u variable. And here, something you need to really consider. So this is 0 and 1. This is in terms of the x variable, correct? This is the interval in terms of the x variable. Since every variable has been changed to the u, this interval also need to change in terms of the u variable. That's something you need to consider. So what we're going to do, we know that u equal to 3x second minus 4. So if I have to convert 0 in terms of u, 0 second minus 4, negative 4. And then 1 is going to be 3, 1 to the second minus 4, negative 4. So this x interval, we convert it to negative 4 to negative 1. This is in terms of the u variable. So that's you're going to convert it, okay? So make sure, oopsie, here, very important step. Because you are dealing with the u variable, the interval also need to change in terms of the u. Does it make sense? So plugging in when x equal to 0, when x equal to 1, and then you're going to find out the new interval in terms of the u variable. So now we have all the information, guys, correct? So let's set it up. Now 0 to 1, change it to negative 4 to 1, negative 4 to negative 1 in terms of the u. And then 3x second minus 4, or let me just write it all the equation. So we have 0 to 1, x 3x second minus 4 to the 5th dx equal to negative 4 to negative 1. And then we have a u to the 5th, and then x times dx, we got 1 over 60. That means bring number negative 4, negative 1, u to the 5th du. So we're going to take the integral 1 over 6 here, u to the 6 over 6 from negative 4, negative 1. So this means 1 over 36 u to the 6 from negative 4, negative 1. So you're going to do capital negative 1 minus capital negative 4. So 1 over 36, negative 1 to the 6. This is a capital of negative 1 minus 1 over 36, negative 4 to the 6. You can go to decimal, no problem. So it is going to be 1 over 36. This is capital negative 4 minus 4096 over 36. Negative 4095 over 36 as a decimal, negative 113.75. So it's going to be simple number because this is a definite integral. So that's the second part of 1.5. What if we have a specific interval, definite interval, so that you're going to finalize the answer with the simple number. Okay. So pretty much that's it. I'm going to just practice 2 more examples for you to have a better understanding. So don't worry. One thing is here, you need to write something. Don't forget for the definite integral, whatever the interval in terms of the x, you need to change the new interval in terms of the u variable. So that's a key point. Exactly what we did. Because you're converting every x variable in terms of u, interval should be changed as well. All right, so likewise, just 2 more example. Hang in there. I'm going to finish up right there. Example 4. So now you feel better. So there is a definite integral. And then I see you. This x to the 3rd plus 6 has been solved, correct? So this is definitely, we're going to begin with what? Let u equal to x to the 3rd plus 6. So you're going to take the derivative u equation in terms of x, 3x second. 6 going to be 0. And then that means cross multiplication, 3x times dx. Whoa, whoa, whoa. I have dx and there's nothing, so I have to divide it by 3, right? Wait. We have a 4x second times the dx. So we have to convert it something. So step 1, divided by 3. We're going to divide it by 3. So if you do that, what happened? We have 1 over 3 du, cancel, x second dx. Now, then I'm going to multiply 4 on both of sides. So then what happened? We have a 4 over 3 du equal to 4x second dx. Because I'm keep modifying it to find out 4x second dx, exactly this, equal to 4 over 3 du in terms of the u variable. Are you okay with that? So that's what I got. And then what did I say? We need to also change the interval 0 to 2 in terms of the u variable. So we have to just use this. When x is a 0, u will be 6. When x equal to 2, u will be 14. So this is a 6, 14. So that's all you need to change, correct? So we have all the information so far here. Let's take the integral right there. So now it is going to be from 6 to 14. And then we have 1 over radical u times 4x second times dx, that is 4 over 3 du. I can bring the number to the front, 4 over 3, 6 to 14, 1 over radical u du. Are you okay with that? So many people confuse, Professor Ben, how do I deal with this? Simplify what they mean. So 4 over 3, 6 to 14, that is a 1 over u to the half exponent, because the radical is a half. And then that means you can flip over u to the negative 1 over 2 du. They're all same. I'm converting. So now you can take the integral. So 4 over 3 u to the negative 1 over 2 plus 1 divided by that exponent 1 over 2. And then we're going to do from 6 to 14. Yeah? So you can bring this one, flip 4 over 3 times 2 over 1 u to the positive 1 over 2 from 6 to 14. So therefore 8 over 3 u to the 1 over 2, 6 to 14. That means capital 14 minus capital 6. So then we have 8 over 3, 14 to the 1 over 2, 8 over 3, 6 to the 1 over 2. So this calculation is a little bit ugly. So you can go to, if I go to decimal, you can simply type that equation. Just go, we have 8 over 3, and then you do have 14 to the second power minus 8 over 3, and you do subtract 6 to the second. So you have 462, 26.67 approximately. So you can simply 4 to 6.67 is the answer. How you feel? Does it make sense to you? So don't be scared. You never know what kind of function you will deal with, right? Take a look at the structure. Is it composition function? Yes, then use a U substitution method. Got you. So now I'm gonna do the final question in terms of the definite integral one more time. Here we go. All right, look at the structure. What is going on? I see you, and I just need to modify a little bit. This third power, a little bit awkward position. This is actually into the cubic, into the radical. So this means we have f function, radical cubic, and then x second plus 1, this is a g function, has been subbed into that radical. So this is a composition. We know x second plus 1 has been subbed. And then you will change x times dx in terms of u, also the x interval in terms of the u interval as well. So let's do the work. We have let u x second plus 1. That's so obvious. We know, we see that is a sub. So du over dx, 2x, 1 becomes 0. And then du means 2x times dx. So it's getting close. I need to find out x times dx. I just divided by 2 both of sides. So 1 over 2 du cancel x times dx. So you got it. So x times dx, that is 1 over 2 du. Okay, the interval thing. So we have 0, 2. You need to convert it in terms of the u variable. So when x equal to 0, u will be 0 second plus 1, 1. When x equal to 2, 2 to the second plus 1, u will be 5. So 1, 5, that's your new interval in terms of the u variable, correct? So we have all the information, guys. So bring it. So now we have 1 to 5, and then third radical u, and then x times dx, we have a 1 over 2 du. Beautiful. That means what? I'm going to bring 1 over 2 to the front, 1 to 5, third radical u du. By the way, what is this? We know radical u is u to the 1 over 2. 3 with the u, radical u to the 1 over 3, right? This means u to the 1 over 4. So we can convert it. We can keep convert it. This means 1 over 2, 1 to 5, u to the 1 over 3 du. So they are going to be same. So now I can, take the integral. So we're going to take the integral 1 over 2, u to the 1 over 3 plus 1 divided by that summation. That is going to be 4 over 3 plus c. And here's a 1 to 5. I can flip this one. So 1 over 2 times 3 over 4 and u to the 4 over 3, 1 to 5. So there's a no c because we're gonna get the number answer. Just this is capital 5 minus capital 1. So anyway, we got a 3 over 8, u to the 4 over 3, 1 to 5. So now it means 3 over 8, 5 to the 4 over 3 minus 3 over 8, 1 to the 4 over 3. So this calculation is a little bit complicated. Go to Desmo. One more time. So we're gonna have, what was it? 3 over 8. 3 over 8 times 5. 5 to the, we have a 4 over 3. So 4 over 3 minus 3 over 8. We do have 1. It's gonna be 1 anyway, but let's just write all the equations. So we're gonna get 2.83 approximately. So we have approximately 2.83. So when you have a definite integral, which means specific interval, there is no c. Always you're gonna get a simple answer. Simple answer because it is a definite integral with the specific range. Okay, so far in this video, you understood how and when you're going to use a substitution method when you're dealing with the composition function. Got it? So I've been showing you all the work as much as I can. Now you have a better confidence. Take a look at all the lecture notes and the video if you need one more time. Take a look at it again. And you can now complete 1.5. Keep asking and helping to each other through the discussion chapter. And if you have any question, email me. I will stop here. Thank you, everyone. See you soon in the next video. Bye-bye.